Hi, everyone, and welcome to our panel session today. My name is Denise Ruffner. I'm Chief Business Officer at Atom Computing, and I'm really excited to be on this panel with these three exciting startups from all over the world. I think there's a lot of very interesting work going on, and I wanted to use this time to highlight some of the companies that I feel are the real leaders in software development in quantum computing. So let's start off by having Markus Braun introduce himself and his company, and then we will talk to the other two companies as well. Markus.
Hi, everyone. Thank you, Denise, for moderating the panel, and thank you to my other panelists to joining me. I'm Managing Director of Just Quantum. We are FinTech boutique, as you called it in the title, working on quantum algorithms and software and finance, insurance and energy. We work together with our clients on quantum-ready applications. One example is a project together with Deutsche Bank, where we looked at a business risk application. There, the Deutsche Börse faced a technological challenge as they wanted to check the sensitivity of the results regarding the input parameters of this risk model. This would take decades to run on a classical HPC. With a capable quantum computer, we estimated this would only take several minutes to do. So this would bring the business infeasible problem to a business feasible solution. And this is kind of projects we do in insurance and energy as well, together with our clients to define applications for quantum computer together with them. That's about us.
Thank you, Markus. Next up, we have Tennin Yan, CEO of QunaSys. Tennin?
Yeah, Denise, thank you for inviting me, and it's a pleasure to meet you, all the panelists. So I'm Tennin Yan, the QunaSys CEO, and we are a company based in Japan, and we are building quantum chemistry solutions. In Japan. And what we are doing is really similar, like the two things. One is like doing joint research with company. So as you know, that the current quantum computer, especially NISQ devices, they are not discover a lot of algorithms. So we are working with customers to build industrial useful quantum algorithms. And also we have developed a lot of algorithms with our customers. So we implement the algorithms into our tools called Kamui. So using our product, the user can throw the molecules they want to test and just specify several physical properties they want to test. And our system automatically construct quantum circuit and measure it and returns to the user. So user don't have to learn the quantum algorithms levels. And we are in a joint research, we are working with, for example, Toyota Motors or like the ENEOS. ENEOS is the biggest energy company in Japan. And yeah, we are building how that this quantum computer can use for their material discovery. And also, like what we found in Japan is like we are building quantum computing tools. So if people understand quantum computer, they want to use that. But to be honest, not many people understand this quantum technology, so as you know. So like what we did in Japan is like hosting one community called QPark. That stands for Quantum Practical Application Research Community. So there's like more than 50 companies in Japan attended, mainly the chemistry company, but some automotive and electric companies. And we gathered together to learn what is quantum and kind of we do kind of use case discovery. So how can this technology used for each company together? So that is kind of consortium or community we are having in Japan. Nice to meet you.
Thank you, Tennant, and very happy to have Rafael Sotelo here today. Let's hear about Quantum South.
Hello, Denise. Hello, panelists. I am Rafael Sotelo, co-founder of Quantum South. Thank you for the invitation. We are honored to be with you today and excited for being part of your community. We work on optimization, applying quantum computing. We were born at University of Montevideo in 2019, when we became one of the 5 finalists of the Airbus Quantum Computing Challenge. In 2020, we participated in an acceleration program at IoT Tribe, an accelerator based in UK and Spain. And we have just finished a product for aircraft load optimization using quantum computing. It is ready to be applied to real aircraft models with every constraint present in the real world, making operations easier, allowing higher incomes, and saving time and fuel. Airbus has identified this problem as one of the most challenging in the aerospace industry. Basically, the problem can be stated as determining the optimal loading strategy for packaging merchandise in aircraft, aiming to find the optimal configuration of maximizing the loading subject to appropriate constraints. So the idea is maximizing the profit associated to the containers while respecting restrictions such as maximum weight and length, the center of gravity, the shear, and the shape of the fuselage. So optimizing the localization of the center of mass has a significant impact on fuel consumption and environmental protection. So we are working in this area in the aerospace industry. This software supports real aircraft models with 2 decks to fill with containers. The whole software has been tested in real quantum annealer and is ready to work. We are now looking for partners to perform a proof of concept. We also test the algorithm with universal quantum gates computer, but given the limitation on the number of qubits, we can only run programs with smaller size than real case. That is part of our hope to work together in the next months. And beyond that, we are also working on research and development on other cases that are related to this. Our R&D lines are the extension of our quantum optimization algorithms to aircraft fuel optimization during climb phase, and to maritime cargo loading, and to portfolio optimization in finances. That is.
Nico, we can't hear
You
you.
are muted.
All right, sorry. That's some amazing progress. Can we just start off I'd love to hear how old your companies are, how long you've been in business, and how many employees you have, and maybe a little bit about how you were founded. So Markus, can you start off?
So yeah, so all of my colleagues and I have a background in physics or quantum information science or informatics. And we are currently 5 people working on these cases together with our clients, all within a background in, as I mentioned, physics and in the finance background. So software development for finance, or even trading applications, risk modeling in this field, option pricing. So we have these 2 halves of brains, and we just connected this with our company to just bring both worlds in union.
Awesome. And Tennin, how many years has your company been around?
Yeah, so the QunaSys is founded in 2018, and we founded with the Osaka University professors like Keisuke Fuji, that he's the one of the reviewer of the Google quantum supremacy paper. And so yeah, we are founded with them about 4 years ago, and currently we have like the 30 people, employees, and like there's like 4 research side and 4 research business side, and apart from that, it's all engineers building the quantum computers, tools.
Excellent. And Rafael?
Well, we were founded in 2019, and we are around 20 people. We are mainly with our background are computer science and electrical engineering, and with some people with focus in business. And we are in Uruguay, in Latin America, but with collaborators in Mexico from other renowned universities in Mexico, and we have collaborators in Ecuador, and we have also have interns from India, from France, and from some other parts of the world.
It's amazing. So Rafael, when you did your introduction, you talked about your solutions using smaller numbers of qubits and said that one of the challenges is getting larger and larger numbers of qubits. And I'll just do a little plug for atom computing, where we have a system that currently has 100 qubits, and we plan to grow it greatly over the next year. So my question for each of the panelists is, what would you do with a lot of qubits, and how many qubits do you think that you would need, or do you know, to get quantum advantage in your solution? So Rafael, why don't I start with you?
So this sounds very promising for us, since it will allow to run faster this real problem of loading an aircraft, avoiding iterations. And it also paves the way as the number of qubits grows. I think with 100 qubits, we can run a real aircraft, the loading of a real aircraft. But expanding that will pave the way to the test new algorithms that we are developing for larger problems, like vessels, for example, floating vessels.
Interesting, interesting. Vessels are, but how many times bigger than aircrafts? I mean, that's huge.
So yes, they may be more than 50 times larger.
Yeah, that's big.
Because while an aircraft loads tenths of containers, a vessel loads thousands.
Yeah. Tennin, tell us about what you would do with a lot of qubits.
Yeah, so first of all, I think the chemistry simulations, that what's difficulty in the current hardware is the fidelity. So we don't have the high fidelity hardware. So even they have, the current limitation is really fidelity. So even they have like 50 qubit and doing the chemistry simulation, I think kind of, you can call like all the paper is just to choose 2 qubit and just run the variation quantum eigensolver. And that's because of the limitation of low fidelity. So with the high fidelity devices, that is we are really looking for. So that is what we are expecting. And so if we have really high fidelity devices, we are thinking about if we have 500 to 5,000 qubit, we can do the useful industrial applications. So that is, we think that without any error correction, we might do in 500, but we maybe to improve the fidelity more, we do like some partial error corrections. So that will be require like 5,000 or more a qubit. So that is kind of the line we are thinking, and we are looking for like simulation of the chemical reaction that wasn't understand before. That is kind of how we want to use that device for.
That's great. Thank you. Markus.
Yeah, I mentioned in my introduction the case with Deutsche Bank, and there we estimated that we need to solve this real-world problem around 200 error-corrected qubits. So this would bring the real-world problem which they're facing with these sensitivity calculations to the quantum computer. As already mentioned, of course, we need error corrections applied on these 200 qubits, so we have an overhead on physical qubit size. But for applications which are quite near in the future, we think like quantum enhanced machine learning, we think they will be available sooner and doesn't need the full error correction like this model would need. That's just these cases.
Great. And one of my questions is, what level of quantum computing do you see at your customers? Do they have a lot of expertise, or are they relying on you for expertise in translating their problems? Rafael?
We see the customers, they are sensitive to they have in their technological radar, they have quantum technologies, so it is easy to start talking with them. But some of them are making their own workforce, but in general, they are open to collaboration.
And Tennin?
Yeah, I think the situation is really same. So like the really top tier, like 3 chemistry company in Japan, they have dedicated team and 1 or 2 people working on quantum computer and then write code to build algorithms. But the most of the customers, they are have 20% of their effort working on quantum computers. So they have like a lot of their main job, and apart from that, they are using the kind of our tools to test what they want. So kind of it's really needed that people are not dedicated to quantum computer can also use their small time to say leverage the results or for their learns what this technology is. So that is kind of what we are helping them right now.
And Markus.
I mean, it's like you guys said, it's depending on the customer a bit. So some are more advanced in the field and are more keen to explore even in intrinsics or in the company, and some are dependent on some outside feedback. As we are currently in the phase of quantum computing to show the advantage, to enable the possibilities of quantum computing within our industries, if it's finance, aerospace, or chemistry. So we're working together with our clients to show the potentials to work towards as we said, quantum ready application, just to show where within the company is a real possibility for advantages, and where are technological barriers right now, which are they facing, even though they build some workarounds or something like that. And within our current projects, we actually do this kind of work. So we define these barriers, these current showstopper, you could say, and show that there is a possible way when quantum computing has the right capabilities on the hardware side to solve this problem in a real life environment. So this is more, we will technology. Something happened? Okay.
I don't know.
Mhm.
All right. Well, we are running low on time, and maybe we could just focus on your organization a little bit and talk about what your plans are for the next year, so that our audience can continue to watch you and see how you're going to grow. And why don't we start there with Tennin?
Okay, so I will be really straight. So like the quantum, the chemistry application, like based on variation quantum eigensolver, that has a lot of problem right now. So if you want to run that on real devices, you have to do a lot of iteration, do a lot of measurement, and that the fidelity is not good. So we are seeing that problem from when we are started, and we are kind of currently making the research team. So like how can we fundamental improve that algorithms? So how can we kind of do chemistry simulation, but more skip that several process of the variation quantum eigensolver? That is the really big focus of us. So kind of dramatically improves that basic quantum chemistry algorithms. That is our what we are focusing this year.
Okay. And Markus?
So as we always strive to work with our software and our algorithm as close as possible to our customers and to our area where we feel comfortable in, we of course want to grow in this project approach and have of course more customers and work toward that. And especially for this kind of project, we even currently looking for new team members to help us to tackle these challenges. So if anyone out there hears that and thinks that we want to work in an environment between quantum computing and finance and work on interesting applications, just shoot an email to me and we find a way. So we'll really grow on this project side.
Okay. And Rafael, thank you.
Well, we are approaching airlines and airport terminal operators. We are receiving good response from them. So we want to start making a proof of concepts of our software together with hardware manufacturers. We are confident that we will be able to do that in the next months. And and contemporary with that, we are going to continue developing the other lines I mentioned before about maritime transport and about aircraft fuel consumption optimization. So that is our line of growth.
Thank you all for introducing your company and being part of this panel. I'm really excited to see how you progress over the next year. And I'm also going to be very excited to see what you can do with the Atom computer as we put it into beta. So we very much look forward to working with you. And thank you again for being part of the panel.
Yeah.
Thank you, Denise.
Thank you very much.
Yeah.
Thank you for the invitation. Great to share it with you.
Yeah. Bye.